Okay, let's dig into this. We live in a world just swimming in data, right? Billions of IoT devices constantly sending stuff back, but keeping all that information reliable and, clean and actually usable right away. That's a
Mhm.
huge challenge. Think about it. If your critical IoT data gets corrupted, what's the cost? Downtime, people scrambling to fix it, maybe uh, making bad calls based on wrong info.
That really is the core problem,
Why is that?
especially when you need that data, like now for operations or for spotting trends. Traditionally, fixing corrupted data in these big systems, that could mean serious downtime. Really complex, slow processes. Corruption isn't just, a tech issue, it hits the business hard.
Exactly. So today we're doing a deep dive on an architecture that's, well, specifically designed for this smart IoT data problem. We've been looking at this diagram. It outlines a Snowflake setup for recovering from data corruption. And the promise they make right up front is pretty compelling. Auto-detect, auto-recover, and the big one, zero downtime.
Mm-hmm. That zero downtime part, that's what everyone wants for real-time IoT, where you just can't stop the data feed or wait around for hours. This architecture, it lays out a way to potentially achieve that instant recovery.
Okay, so how does it actually work? Let's follow the path shown here. It starts with the raw IoT data sources, stuff coming in, maybe just files hitting storage.
Right. Simple start. That data then gets loaded into your main IoT PROD data area inside Snowflake. That's your live operational data store, ready to go.
And that's where the trouble can start, presumably. If corruption hits that PROD data, how does the system even spot it?
Well, this architecture has a really key automated step, figuring out the exact time the corruption happened. It sets a clear line, basically. Data was good before this point, could be bad after. Knowing the when is the first step to fixing the what.
Okay, makes sense. Detect, timestamp. Got it.
Got it.
Now, the recovery, how does it actually roll back to a good state instantly without, pulling the plug on everything?
Yeah, this is where Snowflake's own features really shine. The diagram highlights two things specifically, time travel and zero copy cloning. These are like the engines driving that instant recovery capability.
Time travel and zero copy cloning. Sounds impressive. Almost like science fiction. Can you give us the quick version? And why are they so important here?
Sure. Think of time travel like an easy undo button for your data tables. You can look at or even restore data as it was at some point in the past, say 5 minutes ago, an hour ago, without needing separate backups. And zero copy cloning. That lets you make copies of huge databases or tables almost instantly, like in seconds. Crucially, these clones don't immediately take up extra storage space. They just point to the original data until you change something in the clone.
Ah, okay. So that's the speed secret. Instead of a slow, painful restore from a backup, which might copy terabytes of data, you're basically using time travel to say, show me the data from before the corruption, and maybe using zero copy cloning to instantly create a clean version to work with or replace the bad one.
Exactly. That's precisely how this architecture uses those core Snowflake features. The diagram shows the flow, corrupted PROD data, then leveraging time travel and zero copy cloning to get to an IoT data recovery state, and then back to a clean PROD state. The speed is the real game changer here.
Interesting, too, it notes that while the tools for recovery are automated and instant, the actual decision to hit the rollback button, that's decided by governance and driven by a business decision. Why keep that human element in the loop?
Well, because even if the tech can fix it instantly, the business needs to, check things. How bad was the corruption? What was the impact? Did we pick the right point to roll back to? Does this fit our rules and policies? The architecture gives you the automatic detection and the instant power to fix it, but actually using that power, that needs to be a deliberate, controlled business choice. It's about controlled recovery.
Right, okay. So let's wrap this up. For you listening, dealing with all this fast-moving IoT data, what's the big takeaway here?
I think it suggests that those long, agonizing recovery sessions for IoT data corruption, they might become a thing of the past. By automating detection and giving you tools like time travel and zero copy cloning, for instance, zero downtime, no data loss recovery, well, it really changes the game for data reliability.
Yeah, it feels like a shift from how do we cope when things break
Hmm.
to how do we build systems where breaks are fixed almost instantly, almost invisibly. That really opens the door for applications and decisions that need data they can absolutely trust second by second.
Mm-hmm. And that brings up a final thought for you to consider. If this zero downtime, no data loss recovery for IoT data is now architecturally feasible with methods like these, what does that unlock? What kinds of real-time analytics or control systems or critical applications that maybe felt too risky before because of data corruption fears? What becomes possible now?